Hi guys, I'm going to do this extra test review with you. Which expression will be irrational? Okay, so the square root of 2 times the square root of 2 is the square root of 4, which equals 2, so that's rational. Rational numbers are fractions made of integers, plus rational numbers will always be rational, so that's definitely rational. So this is the one that's going to be irrational. It actually brings me to this true or false right here. This is true. Rational plus irrational is always irrational. This number here is rational because it's a ratio of integers. This is irrational because it's a non terminating, non repeating decimal. Um, if you try to add those together, they're always going to be irrational. Okay. This is false because sometimes it's irrational and sometimes it's not. Okay, just think of something really simple as like pi plus negative pi, which equals 0. And we all know that 0 is a rational number. Okay, whoops, a little too scrolly. What is an appropriate domain for the number of teachers in this school? Um, I would say either whole numbers, count or counting numbers. I would definitely stay away from rational because you can't have half a teacher. I would definitely stay away from real because, again, you can't have half a teacher or you can't have an irrational teacher. You also can't have negative teachers. So I would stick with something like whole numbers or even counting numbers because really, I mean, you shouldn't have zero teachers, but I guess because then you wouldn't have a school, right? What's an appropriate domain for the number of pounds a person weighs? Now, this can be rational. This can be real, but it should certainly be positive. So I would say maybe real numbers greater than or equal to 0, maybe not the equal to, probably not a good idea, or positive rational. And the reason I'm not saying positive integers or positive whole numbers or counting is because you can have decimals and you can have fractions. So you really want to say rational or real. State whether there is one, none, or infinite. Okay, well, whenever you have the same thing equal to the same thing, that's always going to be infinite. Same thing equal to the same thing, always infinite. So now when you have the same linear terms, but different constants, that's going to be none or no. And when you have different linear terms, that's always going to be 1, which means it's solvable. So, like if I subtracted 2x from each side, that would give me x minus 7 equals 4. And then add 7, I get x equals 11. So that would be one solution. So 11 is the only number that makes it true. Every other number or all other numbers would make it false, therefore not being a solution. All right, solve for x. So I'm going to subtract the 12ab. And that's going to give me 4ax is equal to 12b minus 15ab. So you'll see how I wrote the ABs with the ABs because you can only add or subtract like terms. So ABs are like ABs. Okay, and now I'm going to divide by 4a. So I get x equals 12b minus 15ab over 4a. And, I would honestly leave it like that because there's no a over here in the 12b. So there's no point in trying to cancel out a's. And you can't like partially cancel. Like you can't be like, oh, this a with this a when there's no a over here. Okay, so I would just leave it like that. All right, so solve for W. So basically you're saying, okay, what is going on with the A, the Y, and the W? And that's multiplication. So you just divide by AY. Divide by AY. And it looks a little weird, but you get W equals capital R. Keep the case, like capitals, lowercase, keep the case, okay? So that's basically that. All right, so solve for X. I'm going to start up here, okay? So I get 8x minus 12 equals distributive property 6x minus 8 plus 18. So 8x minus 12 equals 6x plus 10. So since that's an 8x and that's a 6x, I can keep going. There's going to be one solution. So I'm going to subtract the 6x from both sides. And that's going to give me 2x minus 12 equals 10. So therefore 2x would equal 22 by adding 12 to both sides. And then dividing by 2, I would get x equals 11. So 11 is the one solution. If you substitute in an 11, it'll make the equation true. Okay? All right, so here, I'm going to use the elimination of the fractions by multiplying by the whole number 20. I chose 20 because it's the lowest common multiple of 4, 5, and 2. Okay? And so 2/5, 2 over 5, 2/5 times 20, that's equal to 8. 1/4 times 20 is equal to 5. 1/2 times 20 is equal to 10. And again, 1/4 is equal to 5. Okay, so I'm going to subtract the 10x from both sides. And that's going to give me negative 2x plus 5 is equal to negative 5. Subtract 5 from both sides. Negative 2x is equal to negative 10. Divide by negative 2. And x equals 5. So 5 is the one solution. Okay. You can also go with decimals if you want, or you could just keep the fractions and plug through. Okay. Maddie has 4 more dimes than nickels. So I'm going to make dimes 4 more dimes than nickels. So I'm going to make nickels x. I'm going to actually keep it an n just to help you guys with the fact that I'm using nickels so I don't confuse you. So then what I would say is the dimes, they're going to be n plus 4 because there's 4 more dimes than nickels, 4 more. So a dime is worth 10 cents. A nickel is worth 5 cents. And he has $1.45. Okay. Write an equation to find. I don't have to solve it, so I'm not gonna. 3 consecutive odds. So I'm going to use x for the first. And I'm going to use x plus 2 for the second. I'm going to use x plus 4 for the third. Okay, like just picture in your head odd numbers. So like 3, 5, 7. So if x is 3, to get to 5, you have to add 2. If x is 3, to get to 7, you have to add 4. Sometimes a number line would help as well. All right, sum means to add. So I'm going to add these together. All right, x, and x makes 3x. 2 and 4 makes 6. Subtract 6 from both sides. Divide by 3, and x is equal to 23. It's odd, that's good. So 23 plus 2, 25, 23 plus 4, 27. You can do a little check on your calculator, add them up, see if it works. Okay, the length of each side is an equilateral triangle is 12 centimeters more than the length of each square. So here's a square. Okay, so this is x, and this is x plus 12 because it's 12 more. 12 more, add 12. 12 less, subtract 12. I'm going to fill in all the sides. You don't have to, but just for demonstration purposes. Okay, so perimeter is the distance around any polygon. So you have to add all those together. All right, so that's 3 times x plus 12, or 3x plus 36. And that's x, which is 4x's. So subtract 3x, subtract 3x, and 36 equals x. So x is 36, which means this is 36, and this is 48. 48 plus 12. I'm going to just double check that. So 36 times 4, 48 times 3. Yeah, it works. Woohoo! Yay, it works. All right, so this is just the extra worksheet. You can go back and do Regents questions. You can go back and look at the review sheet that was done in class. If you have any questions, you want to use Remind or an email. Have a great night and happy studying. Woohoo!